Section 3.3 Properties of Logarithms. Be the light in the darkness to inspire and to enlighten others. So far we've been talking about exponential and logarithmic equations or functions. And so today we're going to look at something called the change of base formula. And most calculators nowadays, the Casio calculators, some of the TIs will do this. They let you input, for example, this log 7, 2506. Our calculators, however, only have the following keys. So if you notice here, we have the log key, but it doesn't allow us to enter a base. So we have this log on your calculator is only base 10, or you can have base E if we press natural log. So with the change of base, it allows us to still use our calculator. And basically what it's saying is if you have a base other than 10, then we can rewrite this log as log base b of x divided by log base b of a. So in other words, we are going to make this have the same base of 10 or natural log. So if we're looking at base 10, we would have log a of x can be converted to log x divided by log a. And if we're using base e, we can rewrite this as natural log of x divided by natural log of a. So notice that your base a is going to be in the denominator, and then x is going to be in the numerator. So for example, if we have log 72506, we can use the change of base and rewrite this as log 2506 divided by log 7. And so now we can use our calculator to enter our information. So here we're going to have log of 2506 divided by log 7. And so our answer comes out to 4.022. So let's try the second example, log 2 of 12. We can rewrite this as log 12 divided by log 2. So in our calculator, we would have log 12 divided by log 2, and we get 3.58. We can also use natural log instead of log. So I'm going to go ahead and use natural log for log 425. So we can rewrite this as natural log 25 divided by natural log of 4. So in the calculator, we would have natural log of 4, natural log of 25 divided by natural log of 4. And so that comes in to approximately 2.32. If you use the log, notice what happens. So if we use log, we would have log 25 divided by log 4. And so notice that the approximation is the same. So you can use log or natural log. So with logarithms, we have some properties, and these are the properties here. We have the product property. Log a of u times v can be written as log au plus log av. The quotient rule is log base a of u divided by v, and we can separate it as log a u minus log base a v. And then we have something called the power rule. Notice we have an exponent here, so the power rule will allow us to take this exponent to the front of the log, and then we would have n times log base a of u. And these properties hold true with the natural log as well. So notice here natural log of u times v can be written as natural log of u plus natural log of v. So in example 2, we want to write down what this comes out to. So for the first one, we would ask ourselves what's going on in the parentheses here. We're multiplying, so that means we're going to use the product rule. So I can rewrite this as log base 6 of 7 plus log base 6 of 11. If we look at the next one, we have log 100 times x. The base here is 10, since we don't see a base, and 100 and x are being multiplied, so we can rewrite this as log 100 times x. So this would be log 100 plus log x. However, here for log 100, we can simplify that further. So log 100, you can put it in your calculator since it's base 10. Or you can use the ideas that we learned before. So log 100 can also be, there's a 10 here. So basically, what power does 10 have to be to give us 100? And that's 2. And so this would be our answer. And so you can convert this right here to exponential form. So you would have 10 raised to the power of x equals 100. And so the power would have to be 2. For letter C, notice that 23 and x are being divided. So we can use the quotient rule and separate this as log 8 of 23 minus log base 8 of x. So let's try a couple of more examples. So we have log e of 5 divided by 11. Since this is being divided, we can rewrite this as natural log of e to the 5th minus natural log of 11. So in the previous section, we saw that natural log is the same as log base e. So we can rewrite natural log of e raised to the 5th power as log base e of e raised to the 5th power. Since they have the same base, then our answer here is just going to be 5. You could also put it in the calculator. You could have written it as natural log of e to the 5th power and you can see it comes out as 5. Okay, so anytime you have natural log and e, your answer is just going to be that exponent. On the next one here, we have log 8 W4. So notice that here the base 8 and W are not the same. So we cannot apply the same rules that we did over here. And so this is where the product rule is important. Multiplication as log 8 of W times W times W times W, which would then be log 8W plus log 8W plus log 8W plus log 8W. So if we add these 4 together, now we're going to have 4 log 8W. So that's if we don't use the power rule. However, the power rule allows us to look at something like this. Let me just rewrite it. And the power rule tells us that the exponent we're going to bring to the front. So we're left with 4 log 8 of w, which is the same answer that we got here. So to save time, we can just use the power rule instead of rewriting this into a multiplication and then separating it to addition. So let's look at letter F. So here we have natural log of the cube root of x. So 1, I can rewrite this as natural log of x raised to the 1/3. The cube root can be written as a exponent of 1/3. Now I can take this exponent to the front. So I'm going to have 1/3 natural log of x. Okay, so these are the 3 properties that we can use to help us simplify in the next sections. Let's go to the next page. So here it says use logarithmic properties to expand each expression as much as possible. So notice here you have one logarithm. So after expanding, we should have more than one logarithm. So we look at the first one. We have x to the 4th being multiplied to the cube root of y. So I can separate these using addition. So this would be using the product rule, log b x to the 4th plus log b of the cube root of y. And so now we can apply the power rule. So the 4 will come to the front. And here, since I have a root, I can rewrite it as a exponent as a fraction. And so I can bring the fraction now to the front. And so this would be our expanded logarithm. Okay, so what this means is the original log b of x to the 4th times the cube root of y is equal to 4 log b x plus 1/3 log base b times y. Okay, let's try letter b. So for letter b, I can rewrite this as log we have division, so I can separate this as log 5 square root of x minus log base 5 of 25 times y cubed. So log base 5 of square root of x, I can rewrite as log base 5 of x to the half power, half being that the square root, the index is a 2, so this would be a fraction half for as the exponent, minus, I'm going to write parentheses here. Notice that I have 25 times y cubed, so I can separate those into using the power rule, the product rule. So we're going to have log 5 of 25 plus log base 5 of y cubed. It's important to put the parentheses because the subtraction is applied to the entire thing. So now we're left with, I'm going to take the exponent to the front using the power rule. I'm going to distribute the negative into the parentheses. So I'm going to have minus log base 5 of 25. And I'm going to apply the power rule for the y cubed. So negative times log base 5 of y cubed would be negative. Bring the 3 to the front using the power rule. And we want to check if we can simplify anything in here. So notice that we have log base 5 of 25. So if we look at this right here, the power for 5 would have to be 2, so 5 times 5 will give us a 25. And you can convert this to exponential, or you can think of it as log 5 of 25. We could rewrite it as log 5 of 5 squared. Since this base and this base here are the same, then our answer is the power of 2. And so this would be our expanded answer for this logarithm. So log 5 of square root of x divided by 25 times y cubed is equal to 1/2 log base 5x minus 2 minus 3 times log 5y. Okay, so now for example 4, we want to actually condense, meaning that you started with 2 logarithms and our final answer is going to just be 1 logarithmic. Okay, so an important thing here before we get started is the following. So coefficients of logarithms must be 1 before we can condense using the logarithmic properties. Okay, so in other words, if I look at this natural log, the coefficient is a 2. In order for me to start to condense, this 2 must be a 1. So we can start by using the power rule, and we're kind of reversing backwards, so working backwards. So for example, here, y raised to the 1/3 power, we brought the 1/3 to the front. Now we're going to take the number in front and place it in as an exponent. So for example, 4a, here we have the 2. We're going to bring it to make it a power. So we would have natural log of x squared plus natural log, the 1/3, we can make it into an exponent of 1/3. Then we want to ask ourselves, since we have addition, then we can use the product rule and rewrite this as natural log. So for addition, that means that we're multiplying. So I'm going to have x squared times x plus 5 to the 1/3. And so I can then rewrite this as natural log of x squared. Since I have an exponent as a fraction, this is going to be a root. And in this case, a cube root. So that would be our answer. Let's try the next one. We have 2 log x minus 3 minus log of x. So first we want to take care of this 2. So this would be log x minus 3 squared, because we're bringing the 2 to become an exponent, minus log x. Since we're subtracting, then we're going to use the quotient rule. So we would have x minus 3 squared divided by x. Okay, let's try letter B, or I guess this would be letter C. So first take care of those coefficients. So I'm going to have log b of x to the 1/4 minus log b of 5 squared minus log b of y to the 10th power. Then we can combine 2 logarithms at a time. So let's combine these 2 here. Since we have subtraction, then we can rewrite this as division using the quotient rule. So we're going to have log b of x to the 1/4 divided by 5 squared minus log b of y to the 10th power. So now we can combine the next two. So we're going to have log b of x to the 1/4 divided by 5 squared divided by y to the 10th power. Then we can start to simplify. So here I would have log b of x to the 1/4 divided by 25 divided by y10. Okay, so the division here, of course the shortcut is the denominator will now be in the denominator, but the reason that happens, let me just write it on this paper. So if you notice here, we can rewrite this as x to the 1/4 divided by 25 divided by y to the 10th power. Change division to multiplication only if I take the reciprocal. And so this would be x to the 1/4 divided by 25y to the 10th power. So my final answer here would be log b of x to the 1/4 divided by 25y to the 10th power. And actually that x to the 1/4 can be written as log b, it's a root, so this would be the 4th root of x divided by 25y to the 10th power. Okay, so let's try the next example. So here we can rewrite this as log 2 of x plus log 2 of x plus 1, and the power here is, we can bring it to the front. So now we have log 2 base x plus log 2 base x plus 1. So this will be log 2 of x times x plus 1. And we still have this power of 1/3. So we can simplify in here. This would be x squared plus x 1/3, and then the power of 1/3, or the exponent of 1/3, can be written as the cube root and so that would be our answer. So this is the end of section 3.3, and so in the next video I will be discussing 3.4 exponential and logarithmic equations. So the previous 3 sections were meant to help us solve these type of equations here.